now we have the text that we're going to modulate. We have uh, figured out the number of characters that we're going to change. We figured out what we're going to draw from as far as the pool of characters that we're going to change this to. And let's talk about the meat and potatoes, like how are we going to go about mutating this text? We always have to remember that strings in Python are immutable. So if we're going to work with the string, we're going to have to figure out how to essentially create a new string from an existing string. And we can overwrite the value of the string uh, variable, but we can't directly modify it. And let me just make sure that you understand that. So if we say text is this and I wanted to change the first character to say an X, that's not possible. That's what I mean when I say a string is immutable. We can't directly modify it. Whereas if we had a list of items, you remember, from our picnic, if we had items that was chips and soda, we could say items at 0 is now equal to cookies. And if we look at items, then we see it's now cookies and soda. But strings are not modifiable in the same way. Um, that should give you an idea about how you could probably go about solving this. Maybe it would be convenient um, to change your text into a list and then mutate that. But if we're going to stick with using strings, let's figure out how we're going to do that. The first way I'd like to introduce is a non-deterministic way to go about selecting these. And so what we're going to do is basically go through each character in, in the text and flip a coin. And to do that, we can use the random module. We can import random. And there is inside random a function called random that will give us a random number between 1 and 0. Um, and so what we want is if our percent of the mutations, I think that we chose, say, 0.2. If I flip a coin, or I randomly choose a number here, I want, if that number is less than the point of the mutations value, then I could choose to take a random choice from my pool of letters. And if it's over that, then I could leave the character the same. And so it's non-deterministic because as we go through, um, um, you may not actually end up changing the right number of characters. Um, it would be close enough, but it would be difficult to test this. It would not be impossible to test this, but the point is that if we were trying to introduce exactly 8 modifications, this might sometimes choose 7, sometimes choose 9, and maybe most of the time choose 8. I'm introducing this technique because it's extremely valuable, especially if you're processing an extremely large text file, and which I often have to do. It's very common that I deal with text files that are gigabytes in size, and so choosing a technique like this would be very useful in processing a large text file. But in a very small bit of text here, it would give us not quite the right number of answers all the time. Um, so especially as your selection space goes down, this will return very different numbers. So, but let's talk about how to go through this. So going back and choosing, looking at those being our, uh, this could be our substitution space. I'm going to call this alpha. Um, alpha is equal to that. So those are the alphabet characters that I'm going to select. And I'm going to say that, so here's what our text is. I'm going to define a new text. New text equal to the empty string. And I'm going to say for the character in what we have right now as text, I want the new text, I'm going to add to new text some character. And if I were to just simply say character, that would be building up the same string, and it would be character at the end. But what I want is, if it's true that, well, I'm going to make a random choice from the alphabet. If it's true that random.random is less than my mutations value. This is going to get kind of long, so let me make this larger. Um, if it's less than or equal, else I'm going to choose the character. And this is very similar to other exercises that we've done. For instance, well, I was thinking ahead to the ransom, um, uh, but where we go through a list of characters and we have to choose. In the jump to 5, we had to go through each character in the string and choose, do we want to use this character, um, or do we want to translate this character to some other character? Like if this character occurs in our jumper table because it's a number, what we actually want is the value from the jumper table. But if it doesn't occur in the jumper table, then what we want is the character itself. This is exactly the same idea. For each character in the text, either randomly choose an alphabet character from our selection space if it's true that the random number that we draw is less than or equal to the percentage of mutations that we want to introduce, else choose the character itself. And if I run that, then new text um, should look, um, it should have basically 20% of mutations introduced. Let's go back and let's change mutations to be, let's see, 0.7. And let's run all that again for character and text, new text, and then let's look at new text again. And now it's virtually unreadable because 70% of the characters have been randomly changed. This could be also, you could think of this as a way of encrypting text, one of my favorite subjects. So um, if there was a way of knowing how these characters were substituted and then getting them back out, this would be a way of encrypting and decrypting text to send. So that is a non-deterministic way to change the characters. We're not going to use this, but I wanted to introduce it because it's a really clever technique.